Hello, my name is Łapacz from PSNC, and today, together with Tomasz Szewczyk, I will present the application called Maat that we have developed with the team. Of course, we have developed in GÉANT project and WP6 Task 2. So Maat is the source of truth application that stores the information about the intended network state. So it manages information about resources and service instances. As a standalone, Maat is not very sophisticated, powerful application. It's just I would say, simple application with database behind with exposed APIs, but as a component of network orchestration automation system or platform is a powerful tool, and I will prove it and describe it later on the other presenting other slides. Let me also add that this application is compliant with TMF Open Digital Architecture. More about this architecture I will say a bit later. And I want to emphasize that this application, Maat, is already deployed in PIONIER network as a production service, and this deployment happened in the previous year. So regarding the ODA architecture, so we don't have today time to describe in details this architecture, so you can find much more information on this on the TMF website or our WP6 wiki. Let's just say that this architecture is composed of functional blocks with functional components inside. So in case of source of truth and inventory functionality, we should go to the production functional block and find two components called resource inventory and service inventory. These components are defined by TMF. TMF offers also data model for them, definition of REST APIs, and all of this we used for the implementation of Maat. Main features of Maat: extensible data model. The application right now in our deployments use REST TMF data model, but other data models can be also used. The application may support multiple data models at the same time. It's very easy to extend data models, and we have done it for PIONIER use case. Extensions can be done easily using JSON schemas. As I said, the application is powerful as a component of the automation and orchestration system. So for automation use cases, is a very nice tool. The application exposes standard REST APIs. Again, from TMF, we didn't reinvent the wheel here, and it's secure. The application offers authentication of API and authorization to have control access to data stored in Maat. The application, we recommend to run this application in Linux. It's a Java application with Spring Boot free library. Behind we have NoSQL database, MongoDB. We execute the application Docker, Kubernetes, As I said, the application is secure with authentication, authorization, and for that we integrate Maat with Keycloak. As I said earlier, we have production deployment of Maat. We did it in the previous year, but for this year we plan to deploy the implementation of orchestrated network service provisioning, PIONIER, and the key component of this implementation is Maat. We started with layer 2 circuits, but we have much more right at the moment. We have more network services. As I said, we plan to deploy it as a production service this year. We have also a test deployment of service provisioning implementation with Maat in GP4L. More about GP4L initiative you will hear later in Sonja's presentation. We have also a mini site project. We call it mini site project related to Maat. At the moment, two such projects. We hope to have it more in the future. The first one is the integration of Maat with Grafana and MapGL plugin for a nice visualization. The second mini side project is the Maat Java library for simplified access to data stored in Maat. The main API in Maat is, of course, REST API, but some time ago we were asked to develop UI. So we were inspired by Netbox UI, another source of truth application. So right now we offer Maat UI, where a user can filter data, can create new services, resources, delete them, or update. You will see how it works later during the demo that will be presented by Tomek in the second part of this presentation. Here you can see the screenshot. I already mentioned about the side project, the integration of Maat with Grafana and MapGL plugin. Here you can see the screenshot of topology of PIONIER network. At the moment, only topology is presented, but soon also it will be integrated with monitoring system. So monitoring data will also be presented in this nice 3D view. Another initiative that we have is the presentation of events. Maat itself does not store information about changes in the database. For example, when we add new service or remove a service or resource or update them, Maat only stores the current status of network, current information about current services and resources that we have in infrastructure. But we have implemented a supporting application called Event Listener that receives notifications from Maat about events, about changes. So here you can see the integration of Maat, Event Listener, and Grafana with Maat UI to present the history of events. So a user can filter, can search interesting information from specific period of time, can see the details about resource or service related with the event. Another initiative, quite new initiative, is the implementation of chatbot in Mattermost. Why in Mattermost? Because in Pioneer we use this chat application for internal communication, but also our NOC team in Pioneer uses this application. We have implemented this chatbot using Airbot framework, and it's simple client. It's only for the read access, and it's useful especially for NOC staff to quickly get needed information. A set of queries with assigned commands have been implemented, and on the right side you can see the screenshot where a user asked for services running on devices on a specific interface. Right now, the bot gives information about what information that stores that are stored in Maat, but soon we want to also integrate it with monitoring system, so a user will fetch additional information also about monitoring data. Maat is an open source project, so repository with sources is open, is public. Our main repo is available on the Bitbucket service, project service, but the mirror is also available on the GitHub service. Okay, that's all for the first part, general overview of Maat application. If you have any questions, later, if you want to get much more detailed information about Maat, about the functionalities, installation, configuration, we have a very nice website, and you can find all of this information there.
My name is Tomasz Szewczyk. I'm network engineer in PSNC. I'd like to give you the basic overview of our Maat implementation in Pioneer Network. So, as Roman said, we are using Maat applications since last year, but before that it was development work for our automation system in Pioneer infrastructure. We were also involved in cooperation with other GÉANT teams, so you may find here some similar approaches, because we trying to learn also from what other teams in GÉANT community are doing in that matter. So what we've done, we created the data model, which allow us to model and describe our infrastructure as a set of resources and services which will be implemented on top of that. Thanks to Maat and its TMF based background, we defined a set of resources and services already, together with some references between those elements in database. So thanks to that, we can model almost any aspect of our operation and infrastructure. However, what I'm presenting is the current state, but just note that we can extend or change that model anytime, because it's the Maat database is very flexible, so it doesn't require us to change schemas and so on in order to implement some new resources or relations between resources. So we using a set of parameters which describe each object in the database, especially in terms of its parameters related to networking technologies. However, we also defining some workflow processes, like for instance the interface status, because if the device has interface, we can use it for different types of services. So we defining a workflow in order to use the interface to provide services. So as Roman mentioned before, the implementation team developed the Maat UI, which is very nice because it allows us to map all data model elements we defined to database. So as you can see here, as we defined vendor, models, customers, sites, devices, and interfaces, all these elements are covered in Maat UI, and you can distinguish here the resources and the services part, which allow us to nicely display all elements we have in our database. Additionally, the database has quite flat structure, so there is no hierarchy in terms of objects stored in database. All of them are in the same, I would say, level. However, what we would like to do, we'd like to have some hierarchical structure just for us to better understand what we're doing and what are relations between objects. So we defining this hierarchy in namespace level. So, for instance, if we defining a service called layer 2 circuits, then we divided it for layer 2 services, and right now we're implementing circuit, so point-to-point service. And for that service, we have the service instance itself, and we have also service access point, which is object responsible to keep data for interface specific parameters. And similarly, you can see that we are able to on the development instance, we are able to define new services. We can play with different type of data we would like to store in database, because we can easily create those elements and remove them from database. And thanks to Maat and TMF flexibility, we are able to build very complex set of services. Like, for instance, if we will build a L3 VRF service, we can easily use a BGP protocol as a service, as a supporting service for that L3 VRF service. So we can create very, very complex scenarios which will reflect what we have implemented in our real network. So then you can see particular parameters for particular objects in database and see what description, so resource characteristic or service characteristics are defined for that object. And thanks to Maat, you can see this in the nice table view, or if you like, you can see this natively, this data in native format, so as they are stored in Maat database, so JSON format. Yeah, so that's really nice in terms of building new stuff, debugging what in case of problem, or designing new elements in database. So right now, let me switch to online demo. We have a development Maat instance, which we are using to work on deploying new services, deploying new elements in database to test workflows and so on. So as the first element, let's start with routers, because it's most basic part of our infrastructure. So we have a set of routers defined here, and for each router, as you click on that, you are transferred to the particular resource in database. So resources are displayed here. So as you saw on the slides, we have a table view and a JSON view for each object, and as it is defined in TMF, we have resource characteristics. For instance, we have router ID here, or some other parameters, like for instance, management access. But what is quite important and which is what is the strength of Maat and Maat UI is the resource and service relationship part. Basically, what you can see here is you can check here all relations which are created for given object. So in that case, for instance, you can see that the particular router is type of PTX device. It is located inside somewhere in Warsaw and has attached a number of interfaces to it. And if you click, for instance, to the model reference, then you are transferred to a model object which collects all devices of the same type through references. And if, for instance, we would like to define some model-related parameters, then it will be quite easy for us to add this set of features. And instead of replicating data for each device in database, then we can collect them in the same in the same object, in single objects, to avoid replication of data. And additionally, we can go, as you can see here, we can go to vendor, because this PTX model is produced by Juniper, so we are automatically switched to the vendor object. Yeah, so it really in a really nice way allows us to browse and browse the data and see what is the structure of our data in database. Again, if we switch to service part, you can see that we have here a set of objects related to services. In case of layer 2 circuits, which was the service we started development, contains a set of parameters of given services. For instance, you can see that given service has some parameters like MTU or virtual circuit ID. But it has also references to service access point. And again, if you click on one of them, you will be transferred to particular object in database. But it also has a concept of resource relationship. So in our case, we're using it to link given service to customer. And again, if you click to that, you will be transferred to customer object. And for instance, you can easily check for instance, contact data for customer. So you are able to notify customers if something is wrong with service or the maintenance work is planned and so on. So that's how we right now are using Maat and Maat UI for development purposes. And the same instance is implemented in production infrastructure, so it stores real data with our devices, interfaces, and services. I will show you later on. Okay, so thank you.
Okay, thank you, Tomek, for this presentation. I think we can now move to Lukasz and to the nmaas presentation.
I'm Lukasz from PSNC. I'm co-sharing this presentation with Vojdan. Regarding the short agenda for today, I will start off by let's say reintroducing the nmaas concept, maybe a little bit differently than we used to before. Then we are moving forward with some updates on two of the existing use cases that we have for quite a long time now, and then Vojdan will also explain our ambitious plans for a new use case, and we'll finalize with some summary of ongoing activities and plans for the nearest future. So, as I suppose you all recall, nmaas is an open source platform for orchestrated deployment of applications in the cloud. Basically, it's Kubernetes based, so a very popular platform. Very important for us is that it has a multi-tenant architecture, allowing a single instance of nmaas deployment to be used by multiple users, multiple organizations that are grouped in what we call nmaas domains. Yeah, of course, from the very beginning, it was very important for us to have the actual application deployment process as straightforward as possible from the user perspective. Originally, using the portal UI that we have developed, but recently in the past couple of years, we have also added the possibility of so-called bulk application deployments that allowed for a user with proper role in the system to upload definitions of multiple instances to be deployed using a CSV format file, and then the backend components parse such a file and proceed with the deployments of all particular application instances. That is very important and useful in the virtual lab use case. So we have already a wide portfolio of applications available in the portal. So recently we are not that much focusing on extending the portfolio. Of course, this is possible, and we can do this based on user requests. So if someone sees the necessity or has a requirement to include a new application in the portfolio, and he's of course willing to actively use it afterwards, then we are of course happy to add this, edit, maybe in cooperation with the user himself. But nowadays, I think that Helm charts for most of the applications already exist online, so this shouldn't be that much effort. We also tackled the aspect of updating the configuration of applications during runtime. Of course, this is not that straightforward in some cases when an application is running in the cloud and the user doesn't have the access to the shell, to the container running this application. So this is why we applied the GitOps approach, and the configuration files of particular applications are stored on dedicated Git repositories and can be altered by the users over there, and then the changes are being pushed to the container hosting the application, and the application is being restarted with the new configuration applied. There is also an option to use a dedicated view in the portal to view the logs of the application running within the Kubernetes cluster. That allows the users to do some troubleshooting, for example, on their own if the application is misbehaving. And of course, worth noticing that of course we are supporting the eduGAIN federated login option. So all the federated users from the federated institutions have this opportunity to log into at least to the central nmaas deployments. The software is open source, and this is the link to the repository. So along the way, we have identified that you can do a lot more with nmaas than just setting up some network management. What was the initial goal of nmaas and the whole, let's say, nmaas name back in the day was network management as a service, but now recently we have moved away from this name. So now okay, I will mention this in a sec. So we decided to treat nmaas as a, let's say, general purpose platform, and build some use cases on top of it. So a use case is let's say specifically use of the platform tailored to solve some given user problem or target some specific user groups. So by adding appropriate applications to the portfolio, plus in some cases adding some additional software features to the platform, we are able to support new use cases. The ones that we already have is VNOC that we actually have from the very beginning, but now recently we have applied this specific name to it, and we have the fairly new virtual lab use case that allows for organizing hands-on exercises in an educational context. So those use cases have their own nmaas instances deployed and available under those links. And of course, to make this more, let's say, transparent from the user perspective, we have underwent some rebranding process in the last year. So we have changed the logo so that it is lowercase now, just not to make the reference to the network management anymore. We have updated the main documentation website, plus we have also came up with some dedicated, let's say, pages for each use case that clearly explain the benefits and the features for this particular use case alone. So just a brief update regarding the VNOC use case. Of course, VNOC is our production service that is running for quite a long time already. So from the very beginning, we are targeting NRANs and institutions that might not want to or don't have the capacity to run some in-house network management, and they can offload this to a central nmaas instance. Here we are also talking about universities, high schools, primary schools. So any user is actually welcome to deploy his monitoring applications centrally, and then using some what we call a site-to-site VPN, connect his local infrastructure with the applications running within the cloud, and therefore have a secure channel of exchanging monitoring data. In some cases, this when some publicly available endpoints are being monitored, this site-to-site VPN is not even required. But also other examples of the use of VNOC are some research projects that might have some distributed hardware resources to be monitored, or some other development teams that have for example, some services running and would like to have some mean to monitor if those services are available. Yeah, and of course the catalog. I mean the nmaas catalog contains a lot of monitoring and network management related applications, but is not limited only to those. Here are some what we call success stories. I mean, some examples of the users actively using our central VNOC production instance. So on the one hand side, we have Ireland QCI. That is a project within Ireland, and obviously that is building some QCI infrastructure within the country, and they are using nmaas to monitor the infrastructure. I would say that we have a lot of users within this domain coming from several institutions. So this is one example of how nmaas is actively used. So some ICINGA and InfluxDB application instances are being deployed over there. We also have some new domains set up by PSNC and being used to monitor some laboratory infrastructures that were built within some recent projects that PSNC completed. Also, we have some software services running, and those has to be monitored. Plus, we are using the newly added application to schedule the database backups what is very useful for us. We have a GP4L domain as well, and we'll hear a presentation from GP4L in a second. We have, for example, a personal domain, and we have nmaas is hosting the Grafana instance that is actually behind the stats personal.net website, and also we have many other domains there as well. We are offering, for example, Maat application in the portfolio as well for anyone to test it out. And just briefly mentioning that we are now undergoing some infrastructure maintenance process. We are moving to a more performant infrastructure, allowing nmaas to work properly and support users for years to come. We had to switch from the original nmaas.eu domain to the VNOC tailored instance. And this, along with this migration, we are bringing some additional benefits like self-service client VPN, client access VPN portal, so that users can use, download Edu VPN profiles on their own using the web UI instead of nmaas administrator having to provide them with it. We'll now fully support IPv6, and also we are moving away from SAML-based integration with EduGAIN towards the Open ID Connect one. Okay, so this is all from my part for now.
So now we'll be talking about the virtual ops use case briefly. The virtual ops use case was basically the second use case that was introduced for nmaas, and at this point we realized that nmaas can be used also for general purpose application deployment, not only for applications related to network management. So we decided to apply nmaas to the organization of hands-on virtual app exercises, both in a formal learning context, such as universities, high schools, but also in an informal learning context, such as online courses and so on. So the core ideas here remain from previously. So we have the containerization. As the runtime technology, we orchestrate the applications across multiple nodes, and of course, we focus on strong isolation and multi-tenancy. To realize this new use case, which was extensively presented through a dedicated Infoshare and in a number of conferences in the past 2 years, we needed to add quite a lot of new features to the base nmaas software. These features mostly centered around bulk application deployments and bulk user deployments, so that it would be easier to onboard lab participants or students to the system and to ease the management of the applications from the lab manager or professor's teaching assistant's perspective. So basically, the highlight here was that we basically allowed for an infinite number of customizable catalogs to exist at the same time. Basically, each domain can have its own catalog of applications that the users in that domain can deploy. This was facilitated by the introduction of the domain groups feature, where basically a domain group maps to a course in the real world, and on the domain group level, we can specify what applications can be deployable by domains in that domain group. So we continued, of course, to develop the VLOP use case more recently. At the end of last year and beginning of this year, we also introduced some improvements, such as improvements to the bulk application deployment workflow, where we have basically revamped the bulk application deployment workflow to support advanced scheduling, where even hundreds and hundreds of applications can be deployed at once, and the system takes care of carefully scheduling these deployments. So basically in a set it and forget it fashion. We have also introduced improvements to the user onboarding process, where now the VLOP manager can decide whether federated accounts or local accounts need to be used, and respectively, the user onboarding emails will be specific as well. And of course, some general improvements to the overall user experience by introducing some nicer UI elements, such as progress bars for visual feedback, caching for faster catalog loading, and so on. So far, VLOP has been used in practice. So, I mean, the managed instance of VLOP that is offered by the project has been used in practice for 3 pilots. 2 pilots were done at the beginning as a proof of concept at UKIM at the St. Cyr and Methodius University in Skopje, and these pilots centered around the ethical hacking subject. And the second pilot was for an IT service management course or subject. However, more recently, at the end of last year, we also did another pilot with the National Technical University of Athens, the NTUA University. And in this case, they used a network management course which leveraged Prometheus and Grafana to teach students about basics of network monitoring. And of course, these applications were hosted on nmaas. And in this pilot, we also leveraged the more recent improvements to the software as well. So it proved as a nice testing opportunity. Also, at the end of last year, we held a full-fledged hands-on VLOP tutorial as part of the GRES 2024 conference, and the materials, which are quite extensive and provide a step-by-step instruction on how to create a VLOP from scratch, are available on our documentation page, which was just sent by Lukasz in the docs. We also provide walkthrough videos if you would like a more visual experience. So basically the step-by-step tutorial, but converted to a video form. So now we will move on to a brand new use case that we have defined at the beginning of this year. And this use case is basically the nmaas federation use case. So this is at this moment, this is just an idea that is actively being worked upon. And the main aspect here is basically to allow a central nmaas instance to manage multiple different distributed Kubernetes clusters. When we say a central instance, this can be one of the instances offered by the project, but it can be also any nmaas instance hosted on a institutional infrastructure, because nmaas is open source. At the end of the day, what this would allow is basically it would allow to associate Kubernetes clusters with existing nmaas domains. And in this case, the nmaas catalog applications, which are already available, would be deployable on these federated clusters. So basically, nmaas would be acting as a management interface for these different Kubernetes clusters. And this use case can also be used in tandem for vNoc and vLab, as we will see shortly. All of the features which are meant to be implemented as part of this federation's use case will be implemented in the base software itself. So we will not be doing completely new software or making a fork and so on. And it will be available again under an open source license to be reused. So let's dive into more details about how this use case will work. Well, the central nmaas instance will offer the catalog and the whole lifecycle management of the applications, but the applications themselves will be running on customers' infrastructure. This will ensure regulatory compliance, of course, and data privacy, because the data will not leave the infrastructure. And this also solves some major pain point, let's say, with the current nmaas experience, and that is setting up the network connectivity. So in this way, using this approach, there will no longer be a need for complex site-to-site connectivity or even client access connectivity, because the applications themselves will be running inside the infrastructure, and the local network can be used to route towards the deployed applications. We are trying to abstract away Kubernetes completely by defining ways in which this infrastructure onboarding to nmaas can be done seamlessly and basically in an unattended fashion. So our end goal here is not to require Kubernetes knowledge in order to use nmaas federations. At the end of the day, what we're proposing is basically a bring your own infrastructure concept, where you onboard the infrastructure to nmaas, and nmaas manages the catalog, the application configuration, and the whole application life cycle, including upgrades. So this use case will be piloted by Renater, which we like to call the use case sponsor. And basically the situation here is very interesting. So in France, there are multiple points of presence, POPs, around the country. And at each POP, there is some network infrastructure, of course. In each POP, there is a dedicated monitoring server that needs to monitor the infrastructure within the POP. And this management of so many different monitoring servers across all of the POPs is something that's really tedious for the Renater team. And we plan to introduce a central nmaas instance, and each POP to basically have its own Kubernetes cluster, which will then be added to nmaas, to the nmaas federation. And from within a single domain, we will be able to ensure consistent application deployments and consistent application configuration across all of the locations. So we hope that this nmaas use case will prove popular, of course, and interesting. And we hope to share more details in the future. So now back to Lukasz regarding ongoing activities.
Yeah, it's only a minute from my side. So we are currently finalizing, or rather deploying, in the process of deploying the new 1.7.0 release of nmaas that comprises some of the features that we already mentioned during this presentation, like this OpenID Connect support. Yeah, regarding this, we are also in the middle of the process. Oh, sorry. I mean, because we had to migrate existing users to a new infrastructure. This includes also some accounts that were created on the old database. And considering this switch from SAML to OpenID Connect, we also had to pay additional attention to this process so that we ensure that the account migration is seamless. Yeah, this release included a lot of improvements, also some major upgrade of underlying Java and Spring Boot. So this is a usual stuff. Then now we are starting to focus on delivering features for the federations use case, as mentioned by Vojdan, including the multiple Kubernetes cluster management option, of course, allowing users to select the underlying Kubernetes cluster on which his application instance should be deployed. This is just in the a short explanation for these features. We also plan to add as soon as possible webhooks support that would allow for integration with external systems, and also it would allow even us to apply and develop some more sophisticated workflows for user provisioning and environment setup for our managed instances. Yeah, last but not least, just wanted to mention that we are also working on some user interface redesign. We will introduce, for example, some dashboards that would display more relevant, the most relevant information for a given user, considering his role in the system. We also support dark mode that might be appealing for some users. Okay, and this is the last slide. We are putting more emphasis starting this year on promotion activities. We have created a dedicated Discord server to facilitate discussions with the users using this platform. We also set up a dedicated nmaas user group on LinkedIn. I mean, you can scan the QR codes here, but also Vojdan is sharing the links in the chat, and we'll also start on frequent basis populate and add some blog posts on our main documentation page, giving some insight to the nmaas features and the use of applications that nmaas supports. So thank you. This was all from our end.
Hi everyone, from my side, I'm Sonja Filiposka. I'm coming from UKIM as well as Vojdan. I know you already heard a lot of things in this Infoshare, so I'm sorry, I will introduce just one more, GP4L. It was mentioned several times, so I will just briefly take you through what is GP4L and how you can use it and what it offers you, and then give the floor to Tomek to actually show you a use case of GP4L and our collaboration with the team from PIONIER. GP4L stands for the Global Platform for Labs, and it has been revamped during the last year into something that we are trying to provide as a comprehensive ecosystem for you to be able to experiment, to innovate, to collaborate on any topic that starts from network programmability to any type of new networking practice, orchestration, virtualization, automation, anything you have in mind. We try to do that by providing you with an access to experimental facilities, which are geographically distributed, so you can do any types of network experiments, even including global network experiments, but also provide you with a software environment where you can do testing, validation of all of your solutions in a safe, closed environment before you put it into your production network and you try to use it for your production devices. All of this is, of course, supported in a co-creation fashion. So that means that the GP4L team, provides you with any type of support you need during the whole process of using the experimental facilities or developing the software or testing and validating the software. The service is open to anyone, so network engineers, managers, net DevOps teams, from NRENs or from research and educational organizations, no matter if they are individuals or groups, anyone who is interested can try to use a part or the whole ecosystem that GP4L provides to you. Basically, it's divided into three separate components. The first component is the experimental testbed I already mentioned. It's actually a P4 distributed infrastructure where you can run your network experiments. The second component is what we call the so-called GP4L playground, which is a sandbox empowered by nmaas, where you can spin network management containers or any type of other software, as you heard before from Lukasz and from Vojdan, and all of the possibilities that nmaas is offering. The last part is the whole expert community around all of these activities, which allow you to start any open discussion on any topic, ask for support, or collaborate on projects, such as the project and the pilot that we have with PIONIER for service provisioning that Tomek is going to show you right after this. For the experimental testbed, what GÉANT has is a number of devices in the form of P4 switches, which are the physical experimental infrastructure core from the GÉANT side. However, we also have very strong partner relations with other institutions all across the world that also have their own experimental devices. So basically, there is a full global footprint of devices that you can use to run any type of cutting-edge network experiment. So if you would like to do something with them, please reach out to us, and we will try to help you put everything you had visualized into practice. On top of this hardware experimental testbed, you can run any type of application, try any type of network implementation you envision using the GP4L playground, which is hosted by nmaas. What we were doing in the past is solutions that are focusing on orchestration and automation, using different types of sources of truth or orchestration engines, defining workflows, implementing GitOps, using different types of APIs. We also we're working on different stuff, such as using digital twins, for an example, for dry run verification, or right now we are working on implementing different types of network visualization where the visualization graphics are developed as code as well. Everything that we do inside the GP4L team, we try to develop it in a generalized, in a modular way so that people can reuse it as a whole or just parts that they would like to reuse. Everything is available as open source code together with documentation on this link where the official GP4L website is available, and it was already seen on different slides, but I will also show it to you in the end as well. Just to give you a taste on what kind of different experiments and use cases and things you can do, here are just some examples for which GP4L has been used or is still being used right now. For an example, the team from Brazil, they developed a very interesting source routing paradigm, which is called Polka, which is very popular and very much used in the research community all over the world. CERN has also been using it also to develop routing and forwarding strategies based on site tags for IPv6 packets. GP4L has been used in a huge number of different types of supercomputing demos over the years. Just last year, we had something like 4 or 5 demos in which different parts of these experimental testbeds were used to showcase different topics such as network security or large data transfers or anything. I already mentioned the development of digital twins, also the orchestration and automation use cases like Tomasz is going to show you, and the interactive visualization that we are doing right now for Grafana. What is important to remember is that all of this is available to you for free. So it's open to anyone who is interested, and these components can be used independently. So you can just contact the community and start working with them, or you can also use the playground, or you can just use the testbed, whatever you need. We are here to support you, and the service is of course maintained by the task in the GÉANT project, and will stay and run during the project lifetime. How you can use the GP4L service, here is a very short step-by-step manual. Just drop us an email. After the email, you will receive a VPN profile. And then if you want to use the testbed, you can make a reservation on our booking system. This reservation is going to come to the GP4L admin, who needs to validate the reservation and make sure everything is okay. And then you will be notified via email about the status of your reservation, if you're authorized to use it. When the day comes, you want to use the testbed, you just check in, connect to the Bastion virtual machine, and you can talk to the GP4L devices and do your experiment. So it's quite simple, it's quite easy, and as I mentioned before, we are here to support you in every step of the way, so you will never be alone and you will have everything that you need. That's all from my side. So as I mentioned before, this is the official webpage of GP4L, where you can take a look, more detailed information about the service, about use cases and different things that the team is working on. And now I will give the floor to Tomasz to show you one use case, which is the pilot service provisioning for PIONIER. Tomasz, you're up.
Okay, thank you, Sonja. So let me give you a brief overview of one of GP4L activity we participating in. So it's service provisioning workflow, and we implementing this as well in PIONIER infrastructure. So what's the I would say basic building blocks and components we using. So first of all, we have a Maat database, which is our source of truth. So it contains all information we need to think about provisioning and building services. The next component is Airflow, which does the stuff related to building all tasks, processes, and performing interactivity between different elements of the system. And we have lightweight service orchestrator developed by GÉANT team, which is used to communicate with devices and push the configuration to devices. So what is the use case in case of PIONIER? We're using a Maat UI interface in order to build and enter basic data for service we want to provision. Then those data are sent to Airflow. Airflow is doing all magic stuff related to communicating with Maat database to see if data provided by user are valid, if we can provision given service. And then if everything is fine, service is implementable in Maat, then is implementable with resources we have defined in Maat, then the configuration is pushed to parameters are pushed to LSO, which renders the configuration for particular type of device. And additionally, what we're using is the Mattermost chat application, which provides us ability to have some information or status of the provisioning process. So right now, I would like to go to online demonstration. So first, as I showed you on previous slide, we're using Maat UI form, which give us ability to provide some basic service parameter. In PIONIER network, we deployed on production infrastructure layer 2 circuit, so it's E-line service, which builds point-to-point connectivity for Ethernet frames. So in this form, you simply type some name for the service, give you basic description. You can link the service with particular customer or customers. And then basically you select from the devices which are defined in Maat database. You're selecting device. Then on device, you select interface, which has proper configuration. And then you provide, for instance, number of VLAN ID number, which will allow you to distinguish different service instances on physical interface. And then you have some common parameters for this type of service you can select. And on the other side, you will do the same. So you will select the device on the other end of connectivity, interface, and VLAN ID. And after that completed, you will click the submit button, which is sending out the information to the workflow orchestrator. And right now you can see that on the Airflow, we have one running process, which is responsible to provision our layer 2 circuit. This takes some time because the process, the workflow is communicating with Maat, retrieves some important information which are needed, and then is pushing out information to LSO. In production implementation, we don't have this back channel for between Airflow and Mattermost. However, in next step of production infrastructure, this will be available. So right now we have to wait a little in order to service to be provisioned. And after that, we can check if it is done in the Maat database. It should be visible here on layer 2 circuit service list. These are services which are existing in our production infrastructure. So as you can see here, Infoshare circuit appear here, and what we can see, we have the virtual circuit ID provisioned here. We have 2 service access point and customer related to PIONIER demo customer. If again, if we click on given service access point reference, we are transferred to the interface. which is linked to that service access point. As you can see here, we have AE6 interface, which is aggregated interface. So the service access point is terminated on aggregated interface. And again, if you click on that aggregated interface, you see that this interface is hosted on PTX device called PTX-POS.2. And again, the aggregated interface has member right now in this single member of aggregated interface. So the service is provisioned and terminated on devices. So we can check that with using a Mattermost chatbot. We implemented a plugin to AirBot application, which is talking to Maat application. So right now, if we asking about our service, so let's say we can type and service name. So before a while, you can notice that the service was not found in database. Right now, we should we should see some information about that. Okay, so we can wait a while. I think my browser needs to be loaded. Probably. Okay, let me reload that chat window. Okay, so let's try to do this again. Something went wrong, as usually on the demo. So I made that experiment before our meeting. So the trick is what we will get. The system will communicate with Maat database and retrieve that information from Maat and present to the user. So with that chatbot, you can check information about not only single service. You can also check information about services terminated on physical interface. So having that, for instance, you can see what type of circuits are connected to our GÉANT access interface. And again, you can also display some information related to given customer. Yeah. So for instance, if we'd like to see which services are related to GÉANT, then we can issue a comment which will display for us all services related to our GÉANT customer. It doesn't mean GÉANT is our customer, but customer represents entity which is responsible or connected somehow to given service. Okay, so that will be all from my side in that term. Sorry for some inconvenience, but this is also, as Roman said, we deploying that on production infrastructure. So that's the initial phase of testing. Our plan is to be ready to deliver this as production service till the end of this year. So thank you very much.
Thank you very much, Tomek, and Sonja for this presentation about the TP4L